The shape of things to come.
Terminate automatic.
An orbiting space station the size of a city, with a shuttle service to Earth.
Visual 8128.78. 0, minus 1 hour and 15 minutes and holding.
A vision of the foreseeable future when space exploration will have become space exploitation. This Russian dreamed of such things. Born a century before the Soviets launched the first artificial satellite, Konstantin Tsiolkovsky, father of rocketry mathematics. The American physicist Robert Goddard put theory into practice. He experimented with homemade rockets. Some thought him mad. But Goddard knew that only a liquid-fueled rocket carrying oxygen could work in the vacuum of space. He launched the prototype for a new age. It was the Germans in World War II who developed the rocket. They built powerful missiles to hit cities like London. The triumph of launching the space age fell to the Soviets. From a secret firing in Kazakhstan, a Vostok rocket thrust towards Earth orbit. There it delivered a tiny Sputnik. The world had its first man-made satellite, the date October the 4th, 1957. Two months later came a Sputnik, 6 times as heavy, aboard the first space traveler, a dog called Laika. The Americans countered with a Flopnik, a disaster that had them in search of a new designer. Meanwhile, in the strictest secrecy, this capsule was being prepared by Soviet technicians to carry the first man into space. It would sit on a mighty new Vostok rocket. But who would sit in the capsule? The Soviet Union's first cosmonaut would be selected from this group of service personnel, and his aptitude would be tested to breaking point. The man to emerge was a test pilot, Air Force Lieutenant Yuri Gagarin. It was 1961, height of the Cold War. As the gigantic Vostok launcher was assembled, the Soviets were banking on another propaganda victory. The race for space had become East versus West. Gagarin couldn't have been cooler. But at the launch site, preparations were frantic. The Americans had already announced an attempt for May. With a month in hand, the first man in space had to be Soviet. Thus, on April the 12th, 1961, Yuri Gagarin set forth. If he failed, the world might never know, for the media blackout was total. Do svidaniya from Sergei Korolyov, the Soviets' brilliant space chief. 4 strap-on boosters and 33 engines carried Vostok aloft. The objective was one Earth orbit. Gagarin's capsule was in the nose cone, a P to be shot into orbit as the boosters and rocket fell away. Gagarin was in space. The world marveled. 23 days later, the Americans responded. A puny Redstone rocket lobbed Alan Shepard into a 15-minute suborbital hop. Stung by the Soviet lead, President Kennedy announced that America would have a man on the moon before the end of the 60s. The Soviets answered with the first woman in space, Valentina Tereshkova. But by now, the Americans were also seasoned orbiters. In 1963, this was the last splashdown of their Mercury program. Next, they announced, would be the 2-man Gemini series, replacing solo missions. Again, the Soviets got in ahead. They crammed 3 men into a capsule built for 2. So cramped, they flew without spacesuits or ejector seats. A few months later, just days ahead of the first Gemini, Alexei Leonov became the first cosmonaut to walk in space. It was 1965. The Soviets had done it again. With Gemini, America was to shrug off Soviet triumphs and concentrate on getting a man to the moon. This meant testing equipment, training astronauts, and maneuvering in orbit. Vital work, for rendezvousing and docking in particular, would be the key to a successful lunar landing. On Gemini 4, Ed White had become the first American to walk in space. An astronaut's view as Gemini leaves orbit for Earth. The flashes are atmospheric friction against the craft. The Gemini program ended in 1966, the bridge between the tentative steps of Mercury and the great adventure of Apollo. Three years later, a Saturn rocket headed for the moon. This was Apollo 11. 3 days later, its flimsy lander module, Eagle, was dropping towards the unknown.
Forward. That's 40 feet down, 2.5.
Aboard, astronauts Armstrong and Aldrin.
4 forward, drift into the right a little. That's okay. Contact light. Okay, engine stop.
We copy you down, Eagle.
Kennedy's pledge was fulfilled.
Tranquility Base here. The Eagle has landed.
It was July the 20th, 1969, and the decade still had 5 months to run. They'd made it.
That's one small step for man, one giant leap for mankind.
And mankind could watch on television. Live pictures were transmitted to Earth. In case a quick getaway was necessary, Armstrong collected contingency samples. But all was well at Tranquility Base. The astronauts spent 2.5 hours outside the lander. They set up instruments and gathered 20 kilos of moon rock. After 21 hours, 36 minutes, Eagle ascended towards the orbiting command module. There'd be more missions. What few people knew was that the Soviets had been simultaneously trying to land. As the lander module Eagle safely returned the first men on the moon to lunar orbit, America's Space Administration NASA knew that a rival craft had crashed. This Soviet robot had smashed into the lunar surface while Eagle was landing. Only after the breakup of the Soviet Union were its lunar ambitions revealed. This rocket, bigger than Apollo 11's Saturn, was to put a man on the moon in one powerful shot. The cosmonaut was to make a spacewalk to transfer to a lunar lander, a scheme all the more hazardous for being a solo mission. But there was every chance of the Soviets landing a man on the moon in 1968, a year ahead of NASA. That there wasn't a glorious Soviet homecoming was due to the death 2 years earlier of Sergei Korolev. An unmanned program continued, but with Korolev had gone his inspired leadership in design and engineering. The Soviets had to content themselves with a few kilos of moon dust returned to Earth by robots. The moon belonged to the Americans. It was no time before the arrival of Moon Buggy. There were 6 Apollo landings. But they were political rather than scientific undertakings, a confirmation of America's preeminence. Although only one scientist got to the moon, lunar samples were obligingly gathered. In 1/6 of Earth's gravity, hopping was the best way to get around. Dust and rock were carted back for analysis. Years later, their study suggested that the moon was the result of a collision between Earth and another planet. It was also confirmed that water and oxygen could be produced from lunar soil. That meant permanent self-supporting moon bases would be possible, even if one pioneer found it difficult to keep his feet. And so for home. Without a hitch, the lander clears the surface to reconnect with its command module. But those heady days have gone. NASA had spent billions of dollars on the Apollo program, and America was fighting an expensive war in Vietnam. The last Apollo splashed down in the Pacific in 1972. Since then, nobody has returned to the moon. Apollo's leftovers were concentrated on Skylab, an Earth-orbiting space station built from the tank of a Saturn rocket. Astronauts and scientists spent more than 500 days aboard this celestial laboratory. Meanwhile, the Soviets had Salyut, a whole series of successful space stations. Crews spent months in orbit. They proved the human body could survive prolonged periods of weightlessness. This was a European rocket. A joint effort by France, Germany and Britain to get into space. Today, it's become the 13-nation European Space Agency. Here, an Ariane launcher blasts off from Guyana. Ariane has proved reliable and commercial, efficiently delivering a stream of satellites into orbit. In 1981. NASA had put all its resources behind a radical alternative to the rocket. Space Shuttle. The launch of a new, cost-conscious era in manned space flight. Shuttle went up like a rocket, she'd orbit like a spaceship, and she'd land like an aircraft. The all-in-one reusable space vehicle. And this is how she worked. At a couple of minutes from liftoff, the two spent booster rockets fell away. They'd be recovered and used again on later missions, up to 25 times. The boosters gently parachuted into the Atlantic. At 9 minutes, the fuel tank was jettisoned like a discarded can of cola. Shuttle eased into orbit. The stuff of dreams, not least for moon veteran John Young, who commanded this first shuttle, 20 years to the day since Gagarin's flight. The massive cargo bay, big enough to accommodate the Soviets' entire Salyut space station, was Shuttle's raison d'etre. NASA mothballed its rockets. With the payload doors open, the crew should be able to launch satellites, do repairs, make pickups. Reality was rather different. There were hitches and delays, and keen competition for satellite launches from Ariane. But Shuttle had much to offer. For a crew of up to 7, there was space to work, to set up experiments, and to live. Compared with the cramped conditions of earlier vehicles, Shuttle was a cruise ship with an onboard gymnasium. By the mid-80s, Shuttle had proved a qualified success. She'd gone commercial and even carried passengers. But on January the 28th, 1986, the program faltered. A ruptured fuel seal caused disaster. All 7 aboard were killed. Shuttle didn't fly again for 4 years. And when it did, it was a strengthened vehicle with a modified brief. Shuttle made fewer flights. To some, it was still a prototype. Its crews, trainees in the business of maneuvering and walking in space. An advance guard in NASA's next great objective. The delivery and servicing of satellites would continue, but the construction of a vast multi-nation space station called Freedom is Shuttle's task for the 90s. A springboard to the moon and the planets, an orbiting interchange, served perhaps by a new super shuttle. While America's plans for a manned space station were still at computer stage, high over Earth, another orbiter had been busy for years. A workshop in the sky. It was the Soviet station, Mir. The word meant peace. A complex assembled module by module since 1986. Crews commuted to Mir by Soyuz ferry. Foreigners participated. There were lucrative commercial contracts. A link-up with the American space shuttle was planned. Mir was so successful, it survived the demise of the Soviet Union. Less fortunate was the Soviet version of space shuttle, Buran. Pictured here on the back of the world's most powerful rocket Energia, Buran flew by remote control. Lifted into orbit by Energia, Buran had one unmanned flight and a doubtful future. Russian ambitions could now lie with the projected European shuttle, Hermes, here with its mini space station, Columbia Free Flyer. A joint venture with the European Space Agency is a possibility. The Japanese are also interested in a manned mini shuttle. But the Europeans' biggest push will continue with Ariane. This is Ariane 5, planned as the world's most efficient launcher, capitalizing on an unrivaled record in the deployment of heavy satellites. Ariane 5 should keep the Europeans ahead of commercial rivals in America, Russia, and China. Space Shuttle will remain America's orbital workhorse. In the late 90s, it'll help construct the great space station, Freedom. Freedom is still being planned, but it should look something like this. A collection of bolt-on modules, American, Japanese, European, even Russian. An orbiting United Nations, courtesy of NASA. Shuttle will be invaluable, but possibly too small to ferry the heaviest parts aloft. Freedom will be permanently manned, at once a research laboratory and a platform from which to launch missions to the moon. Shuttle, however, will be eventually phased out, at least as presently designed. The trouble with Shuttle is capacity. It's a taxi rather than a truck, and a costly taxi at that, adequate for carrying small payloads into orbit or launching modestly ambitious probes. But for powerful shots to the outer planets, NASA must rely on rockets like Titan IV. This could be the next shuttle. A hybrid, half aircraft, half spacecraft. A space plane that could travel from New York to Australia in 45 minutes. or from airport to spaceport in less than half an hour. The technology exists. Indeed, the US military possibly has a smaller version. For the time being, though, NASA is constrained by development and production costs. Sooner or later, Super Shuttle will happen, probably early next century. And towards the end of the 21st century, such hybrids could be joyriding through the friction of the upper atmosphere. Tourist excursions heading for leisure wheels in the sky. A weekend break, watching the Earth below and heavens above. It's science fiction, but as technology advances, there's every possibility of space cities in permanent Earth orbit. Slowly rotating wheels offering visitors a touch of homely gravity. A more immediate prospect is a manned return to the moon, last visited in 1972. How much easier to land in the first decade of the 21st century. And with old rivalries buried, NASA hopes for an international effort. A lunar base would be established. With Shuttle as a kickstart, NASA has longer-term plans for manned missions to Mars. Technologically, they're already feasible. Cost is the problem. Initially, there'd be a touchdown on the tiny Martian moon of Phobos. There, astronauts would set up a sort of base camp. Meanwhile, using the thin Martian atmosphere as a brake, a lander would descend to the red planet itself. An enormous enterprise. The round trip from Earth to Mars and back would take 2 years, and vast resources. The objective would be a permanent Martian presence. The priority to erect airtight shelters, for Mars is cold and arid, its atmosphere unbreathable. Complete with oxygen backpacks, explorers would wear pressurized suits and drive Martian rovers. They'd search for water, possibly trapped as ice beneath the surface. Water would be a boon. Oxygen could be extracted for breathing supplies, hydrogen to fuel the rovers. Every scientific device would be employed to establish self-sustaining colonies. After all, the nearest supplies would be a year away on Earth. NASA, no doubt, will send manned expeditions elsewhere within the inner planets. The outer solar system will remain the preserve of robots. When the robot Galileo slots into orbit around Jupiter in December 1995, it'll have been heading from Earth for 6 years, a journey too far in conditions too harsh for anything but a mechanical explorer. A little later, another mission best left to a robot. A one-way ticket to investigate a comet. And shortly after the turn of the century, a rendezvous with Saturn by the orbiter Cassini, another odyssey unlikely as a manned flight. Beyond the planets, where even robots can't reach, instruments like Space Telescope must probe and explore. An eye on the cosmos for flights to the stars. Had Christopher Columbus been so lucky, he'd have sent a robot ahead before setting out for the New World. In the late 1990s, this Russian robot should be exploring the new world of Mars, reconnoitering for a manned landing. And this American robot could be gathering Martian samples for dispatch to Earth. The vehicles are planned as international ventures. They'll be designed to deploy miniature robotic explorers. This American smart rover will have a mind of its own, the ability to select packages of soil and rock for analysis back home. With the courier aligning for blastoff, the rover will trundle away to seek another consignment. For the courier, a quick ascent through the wispy Martian atmosphere and orbital rendezvous. Untouched by human hand, the transfer of a package from Mars for shipment to Earth. Run by robots, the consummate cosmic courier. But robots are nothing new, especially for the Soviets. This early rover was built to explore the moon. Under test here, it was to be remotely controlled from Earth, a development spurred by the failure of the Soviets' manned program. Lunokhod, as it was called, worked successfully on the moon in the 1970s. A substantial vehicle, its main task was to return television pictures. Subsequent Soviet robots returned lunar samples. They were shipped to Earth in a craft that looked like a mini Kremlin. The two Voyager probes launched by the Americans in 1977 have been the most successful robots. Powered by nuclear rather than solar energy in the dark outer reaches, they've unveiled the giant planets like Saturn. A super Voyager will return to Saturn early next century. Its name, Cassini, a Euro-American enterprise. Cassini will drop a lander on the Saturnian moon Titan. When Voyager passed by, Titan was shrouded in haze. By soft landing a robot, Cassini should reveal the surface. Titan is a planet-sized moon, and with an atmosphere rich in nitrogen, it's like Earth in deep freeze. That's the fascination. As Cassini departs Titan, it'll slot into orbit around Saturn, a robotic eye that'll have the planet under permanent surveillance. This is a robot with a sting. A scheme by America and Europe, as yet unscheduled, to land on a comet. Not with an astronaut or a robot, they would never survive, but with a hefty reinforced dart, jam-packed with sensors. Like a syringe taking a blood sample, the dart will probe the nature of this dusty cosmic snowball. Then, via the mothercraft, data will be beamed to analysts on Earth. The chunky robot, Galileo, has been on its way since 1989. The American shuttle which launched it hadn't the power for a direct shot. So to gather momentum, Galileo had to swing once round Venus and twice round Earth. The objective was Jupiter, a journey that will have taken this mission all of 6 years. Once there, in 1995, Galileo will go into permanent orbit, and it'll deploy a probe. A kamikaze plunge towards the planet. A single chance. Data must be gathered and zipped to Galileo. Within minutes, the probe will be consumed in the crushing Jovian atmosphere. Less dramatic, but equally significant, is the activity of robots nearer home. Earth is girdled by thousands of them in the shape of artificial satellites. Eyes in the sky that keep the planet under constant observation. Indeed, 3 satellites in geostationary orbit over the equator can cover the globe. A 4th is just a bonus. Satellites work in many ways, for telecommunication, navigation, espionage. They also tell us about our planet. Here, for instance, is Earth's topography. Red and black for the highest regions, light green for the lowest. And this is the planet in relief, with shading to emphasize uplands. These are differing terrains, composite data from satellite. Soil types. Greenland beneath ice with no soil shows black. The ecosphere, ice cover in red and deserts in dark blue and purple. And the world's conurbations, illuminated at night. In green, the concentrations of life in the oceans. Here, the distribution of plankton, the microorganism vital to marine ecosystems. And this time-lapse of the Gulf Stream, the great northwesterly drift of the Atlantic Ocean. Of all satellite images, this contour picture of the seabed is among the best. It was compiled through the American orbiter CSAT by using radar altimeter readings of the ocean's surface. So what we're looking at isn't the ocean floor, but the surface of the sea corresponding to the ocean bottom. In other words, the sea isn't flat. It has humps and hollows that match the ridges and trenches of the seabed. With green as vegetation, this is time-lapse of the growing seasons. Summer in the north. Summer in the south. Again in the north. Global or continental, satellites allow no secrets. Over 52 weeks in South America, they show the picture from the Amazon to the Andes. Voyager did the same from Jupiter to Neptune. Its next encounter with a star will be 40,000 years hence. A robotic rendezvous we'll never share. On mountain tops the world over, astronomers have perched their telescopes. This is the Observatoire du Pic du Midi in the French Pyrenees. And in the hills of New South Wales, a joint Anglo-Australian observatory. In Hawaii, above the clouds, the telescopes of several nations. At over 4,000 meters, they're halfway through the atmosphere. Up here, their images of the cosmos are virtually free of atmospheric distortion. This clear eye on the sky is the world's largest telescope, the American 10-meter Keck. And in South America, high in the Chilean Andes, astronomers from the north peer into space from the European Southern Observatory. The universe is their field of study. To the naked eye, a canvas of tranquility. Through the instruments of astronomers, a restless firmament of life, death, and renewal, and of infinite fascination. On Earth, we're bombarded by information from space, radiation that comes in at the speed of light right across the spectrum. In the ultra-short wavelengths, there are gamma rays. This is a gamma ray observatory in Earth orbit. Further down the spectrum, X-ray. The picture, a pocket of gas trapped in a cluster of galaxies, a hint that one day the universe may collapse. In the middle of the spectrum, the Hubble Space Telescope picks up visible light, ultraviolet, and near-infrared. All the infrared wavelengths are scanned by COBE, the Cosmic Microwave Background Explorer. This, a remarkable COBE picture of our galaxy, the Milky Way. At the lower end of the spectrum, radio waves. Gigantic receivers that search the heavens for whispers from the beginning of time. And in the wavelengths of visible light, traditional telescopes pursue the wonders of optical astronomy. Optical telescopes come in two forms. One is a refractor. Light is simply collected through a large lens and magnified in an eyepiece. It's the oldest type of telescope. The refractor was first used by the Italian astronomer Galileo. The second, a reflector, was thought up by Isaac Newton. Light entering the telescope from the left is reflected back up the tube to a smaller mirror, which in turn bounces the image to an eyepiece. The reflector is the basic design of most modern telescopes. Its main mirror is like a great bucket collecting light. It can be built much bigger than a lens because it's more easily supported. So an image entering the reflector would first bounce off the big mirror, then off the small mirror, and through a focal point to be recorded and stored electronically. Rather than squinting through telescopes, today's astronomers analyze computer images, or they study pictures photographed through their instruments, or spectrograms showing the composition of stars and whether galaxies are coming or going. There's always atmospheric shimmer through even the best placed telescopes. Hence the Hubble Space Telescope, designed to observe the cosmos from the crystal clarity of Earth orbit. But Hubble had a problem. It was out of focus. This is a cluster of stars originally recorded by Hubble. After correction by computer, this is the same cluster. Hubble is now unveiling new vistas. Dust swirling round a black hole. A pair of colliding galaxies. Two more. A catalogue of distant galaxies, impossible from Earth. A ring of debris before a stellar explosion. Matter jetting from a galactic center. The last gasp of a dying star. The shock waves of a supernova. And finally, in Orion, pictures of young stars with planetary disks. Another Hubble first. The 5-meter American telescope at Mount Palomar was the biggest in the world until in 1976 the Soviets built a 6-meter reflector. It was never satisfactory. Today, despite fears that a bigger one could never work, the American Keck is on test in Hawaii. A 10-meter reflector whose deformation can be corrected by a series of small mirrors, integrated like a jigsaw. The Eskimo Nebula, a trial picture from Keck. And a galaxy. Keck will come on stream in the late 90s with a twin. Meanwhile, at their southern observatory in Chile, the Europeans have developed a competitive design. It's called the New Technology Telescope, compared to Keck a modest mirror, but in resolution as good as Hubble. Light from space hits a mirror deliberately deformed to compensate for atmospheric distortion. The mirror will adjust to any distortion so that a shimmering image like this becomes focused like this. The Europeans plan an array of huge telescopes to work in synchronization. They'll resolve pictures of the outer solar system. Optical images as good as those sent from probes like Voyager. Radio telescopes work like optical reflectors, collecting information in vast dishes like this American receiver in Puerto Rico. In England, this is the dish at Jodrell Bank. It's big because radio travels in the long waves of the spectrum. If several dishes are linked, their combined scan makes a powerful receiver, giving finer detail. Here, the Very Large Array in New Mexico. And in time-lapse, the Parkes dish in Australia. Radio telescopes around the world can be hooked up. They can see what optical instruments cannot, in ultra-hot gas clouds, radio galaxies, pulsars, quasars. A radio picture from the center of our galaxy, possibly material around a black hole. Jets of gas being expelled from a distant galaxy. Another radio image impossible optically. Red clouds flanking a blue galaxy. Astronomers puzzle over the significance. And here, radar pictures of the asteroid Tutatis. They were achieved in 1992 by using radio in reverse, by beaming signals from Earth and bouncing them off the asteroid. Even the craters of Tutatis can be discerned. In one field, radio has been unsuccessful. Dishes continually scan the cosmos for signals from other civilizations. So far, there's been no word.
The units Star Trekking and Discovery are both available on video, price $10.99 each. To buy the videos by credit card,